Assalamualaikum warahmatullahi wabarakatuh. My name is SOFEAH binti ASMAN and I am from Group E. So today our presentation is about feature selection and extraction on high-dimensional dataset. So let's begin. A bit introduction about our team. Our team consists of 3 members, which is me, SOFEAH, and then RAIHANNAH, and lastly Nina. The objective of this assignment is to improving the model performance by implementing feature selection and extraction, and also we want to evaluate the performance of both model after implementing and before implementing the feature selection and extraction process. The dataset we obtained from Kaggle online repository, and it comprises clinical and demographic, also lifestyle data from 551 individuals, featuring a total of 44 attributes. It is a high-dimensional data, and the primary target variable is PCOS, yes or no. So this data mainly is to predicting whether a individual has PCOS or not. Methodology, firstly, is dataset selection. A high-dimensional dataset we select from Kaggle, and then dataset pre-processing. The dataset undergo necessary pre-processing steps that are handling missing values, standardization, and data formatting. The next phase is about model building and evaluation. We create a model using logistic regression, and then we did model performance. We evaluate model performance by using relevant metrics and visualize using confusion matrices. And then we did feature selection and extraction. The dataset undergo basic feature selection, filter feature selection, and lastly PCA for feature extraction. And then we retrain the model again with the new dataset. Lastly, we did result analysis where we compare the result from both model and to see if there is any increment in accuracy.
Assalamualaikum warahmatullahi wabarakatuh. My name is Syahira, and today I would like to explain about the feature selection and extraction technique that we use in our assignment. The first one is variance threshold, where we remove the features with low variance that is below 0.1. And you can see here in the code, in the command remove features with low variance, where we set the threshold to 0.1. It means any feature with variance below 0.1 will be removed, and to help the model differentiate between classes. And after that, we apply the threshold the dataset, that is the x underscore imputed, and fit transform function to remove the low variance features and return the new datasets to X low variance, and it will print all the features of the variance threshold shape. You can see here the difference between the initial features shape and the features of the variance threshold shape, that is before 43 and after 42. Okay, next we use the correlation matrix by analyze the correlation between the features and remove highly correlated features that is above 0.8. And this will help to reduce the redundancy and noise in the data. And as you can see here in the code, where the first one we will visualize the correlation matrix by using the core function, and we will use the heat map by use the SNS heat map function. And after that, we will focus on the absolute value of the correlation matrix, that is the correlation underscore matrix.abs, to avoid issues with negative correlation. After that, we will set a threshold that is 0.8 to identify features that have a high correlation, that is above 0.8. Any feature with that is value above 0.8 will be considered as redundant. After that, we will drop the identified feature from the dataset, that is x underscore imputed, using the drop function. It will reduce the number of features and help improve the model by eliminating the redundancy. After that, we will print the shape of the dataset after removing the highly correlated features to see how many features remains. You can see here, before that we have a lot of features. After that, after remove, we will only have 39. Okay, next we will use the filter-based feature selection where we assess the relevance of each feature by checking its correlation with the target variable. That is the PICOs, yes or no. The features with a correlation above zero point 0.1 will be kept. Okay, you can see here at the code, the first one we will combine the feature and target variable, and after that we will calculate the correlation with the target variable using the core function, and we will specifically look at the correlation between each feature and the target, that is picos, yes or no. And after that we will also sort this correlation in descending order so that the features most correlated with the target appears first. After that, we will display the correlation value and print to understand which feature have the strongest relationship with the target variable. You can see here the feature correlation with target, they have because yes or no and the target variables. And after that, we will set a correlation threshold that we define a minimum correlation threshold that is zero point 0.1, and this means only features with a correlation greater than zero point 0.1 with the target variable will be considered as relevant. After that, we will remove the target variable from the list. That is, we remove because what yes or no from the list of selected features because it's the target variable, not a feature we use for prediction. After that, we will filter dataset to include only selected features, and we will display the shape of the filter dataset by print the shape of the new dataset to see how many features remain after filtering out those with low correlation to the target. You can see here shape of the dataset after filtering low correlation features, that is 19. Okay. Okay, next we use the principal component analysis (PCA) to reduce the number of features while keeping 95% of the original data variance. The next one we used to simplify the model by creating new features that is called principal component that summarize that key pattern in the data. Okay, in the code, you can see here to use the PCA, we need to import the PCA first and create a PCA object with the parameter and components is equal to 0.95. And after that, we will print explain variance ratio using the PCA explains variance ratio, which shows how much of the total variance in the data is captured by each principal component. And after that, we will print the number of principal components chosen by PCA and components that were chosen to explain 95% of the variance. This number tells us how many features were created by PCA to represent the original data. And after that, we transform to data frame and convert the transform data into a new data frame. And after the last one is we will print the shape of the new PCA transform dataset to see how many principal components were selected and the new dataset size change. You can see here the last one is the PCA components. Principal component chosen is 15 and the shape of PCA transform data is 15 also. I think that's all from me. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Siti RAIHANNAH. My metric number is 2219358 and I'll be presenting the performance analysis. Before applying feature selection, extraction techniques and PCA, the logistic regression model achieved an accuracy of 86.5%. The precision class 0 is 0.87, for class 1 it's 0.86. However, the recall for class 1 is relatively low at 0.7, indicating that the model missed a fair number of actual positives. The F1 score for class 0 and class 1 is 0.9 and 0.77 respectively, showing a better performance for class 0. The confusion matrix revealed that out of 110 actual negative, 104 were correctly predicted as negative, and out of Out of 53 actual positive, 37 were correctly predicted as positive. The model's main weakness before applying feature selection and extraction is its relatively lower recall for class 1. After applying feature selection, extraction techniques, and PCA, the logistic regression model's accuracy improved to 90.1%. Precision for class 0 increased to 0.9, and for class 1, it increased to 0.91. Recall for class 1 also improved to 0.77, indicating that the model now correctly identifies more actual positive. The F1 scores for class 0 and class 1 improved to 0.93 and 0.84 respectively. The updated confusion metric showed a fewer error with 106 true negatives and 41 true positive, while false positive and false negative were reduced to 4 and 12 respectively. This result demonstrates that feature selection and extraction significantly enhance the model's performance, leading to higher accuracy and a better balance between precision and recall for both classes. In conclusion, the application of combined feature selection, extraction techniques, and PCA significantly enhanced the logistic regression model's performance. The accuracy increased from 87% to 90% with a notable improvement in precision, recall, and F1 scores for both classes. The confusion matrices showed a reduction in misclassification, highlighting the model's increased reliability and robustness. This study underscores the importance of integrating multiple dimensionality reduction techniques to handle high-dimensional data and improve the predictive power of machine learning models for complex health conditions like PCOS.